and you can go to the YouTube site anytime after this afternoon and rewatch it. Okay, so without any further ado, let's go ahead and get started. On my screen and your screen, you should see what is GIS, or at least a part of it. ESRI or ESRI's ArcGIS consists of three main products: ArcMap, ArcCatalog, and Toolbox. You may also have some other companion products: ArcScene, ArcGlobe. There's probably a couple others out there in your software, but most everything we do today will be done in ArcMap version 10.3.1, which should be the current version. And we'll also discuss a little bit about ArcCatalog here in a minute. And then I think Janelle in the next class will get a little bit into Toolbox, where you can do some of the processing. So this is your basic user interface. Two key components to it is the big white area in your screen is the map display, where we'll see everything we're working with, and then a table of contents there on the left. It starts with layers, which is our project, which we have nothing in at the moment. And the toolbars are up top. You can use those. They're very similar to Microsoft Windows and work in sort of the same manner: the save, the print, and etc. Two critical ones to GIS where you can access easily ArcCatalog. There's the little yellow file case button there, or ArcToolbox is the button with the red toolbox. We'll see how today goes with technology. You never know when the software is going to chug. I may have to fill up some space. Here's our toolbox, our catalog. We'll go ahead and close those. Like most software, there's multiple paths to generally get to the same place. Okay, now if I need to add toolbars, I can do that under the Customize menu. There's toolbars, and you'll see toolbars will give a laundry list of various toolbars that we can use. I'll go ahead and check on the tools toolbar, because we can't build anything fun without some tools, and we may add a couple more here later, but that's under the Customize tab, which is a little bit different than maybe your other software. So before we build a map or get started, we need to kind of set up some basic parameters. We're going to do that under the layers in the table of contents. If I right click, you should see some options come up as you would expect, and at the bottom, like typical, is properties. It's going to give me a window to look at the properties for the data frame that I'm building. We'll go over to the General tab, and there, one of the things that you'll see is units. Arc is pretty good at defaulting to a lot of the basics that we use, but you can run into problems if you don't set things up front when you get into some of the more advanced processing. So we'll go ahead and make sure we're working in feet, because that's what we like to do. You'll see there's a lot of different options here that we'll go through maybe in some of the more advanced classes, but I want to cover some of the basics here to get started. We'll set the display and feed as well. Then let's move over to the Coordinate System tab. The Coordinate System tab has, you see right off the get-go, a couple options that you're going to choose to set up the coordinate system for our map. I attached to the webinar a handout which explains better than I can, at least at a basic level, the difference between geographic and projected coordinate systems. Geographic coordinate system is just the way we've gridded off the globe. The projected coordinate system is the math processes included that take that spherical coordinate system and put it on a flat piece of paper. Since we're going to be working with flat pieces of paper, we will be in the projected coordinate systems. There's also a handout that talks about different the different types of common projected systems. Some of them are federal, like UTM, and others are on a state level, and some of them are on a global level. For the most part, we'll be working in state plane. Most of you probably heard that by now, state plane system for projected coordinates. There's a number of options when I click under state plane. They're all to the NAD, North American Datum 83. And then there are a number of different types of modifications that have been done, including the 2011, which is the most recent, which is what your GPS surveying units based off the ODOT cores are using. And previous to that was HARN. If I click on NAD 83 HARN US feet, we will see that I have options for all of the different states. And if I get to Ohio, we have the north zone and the south zone, US feet. Most statewide data is in the south coordinate system, I believe, but if you're in the northern counties, you may be working in the northern coordinate system. So we'll use the south, and I'll apply that as our coordinate system to this map, and you can see that gives it the projection it uses. It's way more detail than I can explain, but the Lambert conformal conic system is how they projected that coordinate system from a globe to a piece of paper. And click OK. And we've got our map basically set up. I'm going to go kind of fast through this today, since you can go back and review the webinar on the YouTube site at any time. Let's go ahead and add some data. Okay, I'm going to do that by clicking on this plus sign. If I open that up, well, let me back up one step before I get ahead of myself. If I click the down arrow, I have different options: add data, add base map, add data from ArcGIS Online. In today's internet and cloud-based world, we have a lot of data that we can access directly through the internet through ESRI. So I'll go to the add a base map. That'd be a good place to start with any project. And you can see it takes me to, connects me to a number of different types of base maps I could use. We'll start with Imagery. And wow, okay, there we go. We're looking at the North Pole just in time for Christmas, I guess. So it doesn't do me a lot of good unless I'm trying to map my way around the world. To find where I'm at, I can use the zoom tools. Again, these are very similar to most other software you've used: zoom in, zoom out. Click on the zoom in and it'll give me the magnifying glass, and I think I see the Great Lakes there. That should get me close to where I want to be. And it should be coming up here in just a minute. I'm trying to go a little bit slower because I know there's a little bit of lag in the webinar and what you're seeing and what I'm seeing. Okay, so I see the Great Lakes, and Ohio's in there somewhere, or at least close to where we want to be. Let's go ahead and add another data layer to our project. If I go to the add data this time, it'll take me to a window that will let me go ahead and navigate through my files to locate some data that I had already collected earlier and then saved to my hard drive. I'll open the folder that has streets, and you'll see a streets shapefile. I obtained this particular file from my county engineer. You'll see a handout also on the webinar that has a list of links to several places you can go to get some very basic data. There's 4 or 5 government agencies, ODOT being one of the major players, as well as ODNR, that provide a lot of basic data sets for free There are other places you can go and probably purchase the same or others, but I think you'll find most of what you need there. And then when you start to get the more detailed information, you may need to look to your county offices, your county engineers, county auditors for more localized data. And of course NRCS, and there's the soils data, and the federal, there are several federal websites where you can get large scale data. Okay, back to the window here, and you'll see that the streets F is a .shp or a shapefile. So shapefile is the basic format for mapping mappable data for GIS data. It's what ARC will read here and pull up into our map and be able to use. There's another format we'll talk about here a little bit later on, but let's go ahead and add that streets layer in. And I got an error because the coordinate system that I set up was different from the coordinate system established to that data set. And rather than go back and look at what I did wrong, we'll go ahead and proceed forward. ARC is very good at making the transformations to convert from one to the other. But again, if things aren't set up all in a uniform coordinate system, from my experiences that we've had errors when you start to do some of the more advanced processing. I'll go ahead and close that. Okay, so what just happened? Where's my data? Let's see, it's down here. Another way I can zoom in to my data is to go over to my streets layer, which you see was now populated in my table of contents. And if I right click on that, and it pulls up my window, I can scroll down to zoom to layer. And it will zoom me right into that layer. You may not be able to see that very well, so another thing I can do is go down to the line here and click on that right underneath the streets in my table of contents, and it gives me some symbology options here. Because of that red, let's change that to yellow real quick. Just click OK. And you'll see now that sticks out quite a bit better on my base map, hopefully. Here's another thing that I like to do at this point in time is create a bookmark. You can see that I've got the county. I don't have the county boundary, but I've surrounded the entire county here, or zoomed into the county level at least. I'll go ahead and go over to the bookmark menu and click Create Bookmark. Let's just call this Madison County template, and this is what I'm creating here. Click OK, and that way I can zoom back to this exact view at any time. You can create bookmarks for projects, for areas, townships, however, and it can save a lot of time panning and zooming around. Okay. There's really two components to GIS data. So if I look at the streets layer and I go back and right click on it, it pulls up some options for me. The third one down here will say Open Attribute Table. I'll go ahead and do that. And this is the table, tabular version of all of the data that we're seeing in, pull that down a little bit here, in the map where all these yellow lines are. Each of these yellow lines is a feature. Each feature is shown here, feature ID, as a row in this table, and there are multiple columns of data. This is a streets layer, so it makes sense that we would find a street name field or column. If I click on street name, I can do some things, including sort that. So let's sort that by sending, and if I scroll through, I'll see all the different street names in Madison County. And if I can find the one I want, There we go. I've got one here named Gwen. If I click on the row and highlight it, I can also right-click and zoom right to that layer, or that feature, I should say. So another way of navigating, you see where the tools are all very intermixed, and there's a lot of different ways to navigate through GIS. I'll close the table, and here's that segment of Gwynn Road, Gwynn Street, or Gwynn Avenue, that feature that row pertained to. I zoomed right to it, and it is highlighted here. Okay. If I go back over and go to selection, I'm going to clear that and remove that highlight. If I want to move around, I just use the hand feature, and that will allow me to pan around my map. Now, the more data I have, the more that I have data connected over the internet, and the slower my processor, the more difficult this may be. Okay, we've zoomed into a site that should look fairly familiar to everyone. Again, I can go ahead and create a bookmark and call this Project at Farm Science Review. And I can go back at any time and back and forth, click on my Madison County template, bookmark, and it will zoom me right back to where I was previously, and go back to the FSR bookmark, and it'll take me to my project. So you can see where setting those bookmarks is save a lot of time if you're working in a large map. Help you find where you're supposed to be. Okay, another thing we should probably do before we get too far along with any good software is go ahead and save it. Very standard file, save the current map document, and it's going to ask me where to save it. And it's going to save it as an ArcMap document, and that will save it as an MXD file. The .mxd file is not going to have all this data in it. It's more just a set of instructions to Arc to piece this whole thing back together. If I close it down and reopen it, which I won't do since it'll take a while, it will redraw all of the connections. The problem with that is if you move any of these data sets, if I relocate that streets shapefile from the folder it was into another folder or another directory or drive, that link will be broken. You'll see the streets under your table of contents with a big red exclamation point, meaning I can't find it. Very easy to get back to. Just right click on that streets layer, back to your properties, over to your source, and you'll see S users, Justin Reinhardt, TDP webinars. That's where that's located at. I can go ahead and reestablish that using the select or set data source at any time if I were to lose that link. This is a good time to mention too, this is something I've struggled with. If I were to close or lose my table of contents for some reason, well, how do I get it back? Okay, if I go to Windows, I can go back and add in my table of contents again. You'll see under Windows there's also another link to get into Arc Catalog. Again, many ways to get to the same place in Arc. Okay, so let's see where we're at now. We've got a couple data sets in here. Let's go ahead and add some more data. Click my add. I'm going to navigate up to my culverts information. Well, now you see something different than I just told you. Instead of that .shp shapefile, I have a .gdb file. This is a file geodatabase. You can also have a personal geodatabase. In your handout is a brief explanation. In the handouts is a brief explanation of the differences between a shapefile and a geodatabase. My experience has been things work a little bit better in the geodatabase. It retains, there's a couple advantages, and one, it retains the all of the information in one file, whereas in a shapefile, if I look at it in Microsoft or Windows Explorer, I'll see multiple files in there. So I like working with the geodatabases. I got one comment. There's some static maybe with the vocals. Hopefully everybody can hear me. Let me know. Let me know if there's any problems. Janelle, let me know if there's any problems. I can stop and start over. Okay, so if I open that geodatabase, I'll see here's my data layer, and it is called a feature class instead of a shapefile. I can add that in the same way I added my streets. It's going to give me the same error because I made that mistake earlier. And here they are. I want to go ahead and change the symbology a little bit on those so we can see them. I'm not sure why they choose the colors they choose, but sometimes they don't work out. You can see them here are a couple little dots that represent the culverts that have been digitized. Let's say I want to learn a little bit about this particular one right here. If I go to my identify button, which is that eye in the circle, and I click on that little dot, it will take me to pretty much that information that I showed you in the table of contents for that particular feature. Here's the ID. Maybe I want to know what size culvert that is. If this data was prepared by ODOT, they should have, and they did, include a culvert material, reinforced concrete, field, span, 66 inches, and no length, but a 66-inch reinforced concrete circular culvert. Okay, so I can learn a little bit about my features by using the Identify button pretty readily. Okay, let's go ahead and add another layer. This time let's go into my land use data. I obtain this. Again, this is a shapefile here. We'll add it in. Uh-oh, another problem. What's this say? Data sources you added are missing spatial reference information and cannot be projected. Okay. Well, you'll see that it'll still come up anyways because Arc seems to be really good nowadays at making those corrections. If I go to the properties on that layer, that land use layer, again, the coordinate system is listed as undefined. Well then, what do I do? Okay, let's open up Arc Catalog, and I'm going to navigate to that data set. It was land use, no projection. Open it up, and I've got options including establishing the XY coordinate system for that data set. Let's go to projected coordinate systems, state plane, NAD 83, HARN US feet, state plane Ohio South, hit apply, add that in. So now I can add the coordinate system directly to that that data.
Hey, Justin.
Yes.
Sorry to, so the reason why that land use data actually came in where it needed to be, even though it didn't have a projection attached to it, was doing your part to a very lucky guess. That land use data, the reason why it came in right is because it was created in the same projection that you happen to have your map in. So it's had you used if you're using any different projection, like UTM, for example, that data would have come in incorrectly and not displayed right. But congratulations on your very lucky guess, or your smart planning.
Thank you.
That's all.
I'm going to go play the lottery now. The point of that, and thank you for that background, is like I said, to not just rely on that guess because it popped up right here. Make sure that you go ahead and make all those corrections. I've had, and you may have data come up and it'll be on the other side of the globe if you get into the situation that Janelle said where it does guess wrong. So let's add another data set, since this is just so much fun. I feel so empowered now that I know how to add data to a map. Let's go ahead and add soils data. Where did I get that? Well, there's a number of places to get really good unofficial data, and the official data set you'll find from the Web Soil Survey you can download, and I did the whole county, and you'll get this file structure when you download it, and you'll wonder what's going on. A few years ago, Aaron Lance, who was with our division, put together good guidance on how to reconnect all of this information, which is all of the fields attached, or they're, in this case, they're separate, and that's the tabular data from the actual spatial data. So I'm just going to go into the spatial data. I'm not going to say that again because it'll start to come out wrong, and add in the soil map units. Okay, so this is the soil map unit polygon file, and add that in. You'll notice one thing that I've added in here are 3 different types of shapes or features. Points, the culverts, you can see as the little dots. Lines, the roads, which you can see as lines, and then the big puzzle that is solid colored is polygons, or shapes of different sizes. So there's 3 different types I can add in: points, lines, and polygons, and I've got a couple of all those in here in my map. So I can't do a whole lot with this at this point, can I? I can't even see my base map. Let's go to the soils, and again, right-click on soils, click on the properties, and our box tabs will come up. If I go to the display tab, well, let me back up a second. Go to the Symbology tab here. The Symbology tab will show me how it symbolized the data as a big, each polygon with a gray outline and purple fill. That's doing me no good. So let's make those hollow. If I apply that, I can see through those. Okay. The other thing I can do is add labels, so I know what each of those polygons represents. If I go to the Labels tab, click Label Features in this layer, I got to choose which one I want to use, and I'll use the map unit symbol. And for now, we'll click Apply. Okay, now I'm getting a big jumbled mess, aren't I? Let's go ahead and turn off the land use layer, and I can see my soils map a little better with those labels on it. Let's go ahead and make that a little more visible, I can always go ahead and change the labels to white, change the symbology, change those hollow lines to yellow, click OK, click Apply, and maybe I can see those units a little better. Same thing, I can use the Identify button, click in any of the polygons, and it will give me information. You'll notice what it'll do is it's giving me an option to choose what I'm seeing. The attributes to, in this case, the topmost layer, meaning the upper layer that it found drilling down from my table of contents. Since I bypassed any culvert and any point or any street line, it took me straight to the map unit symbol. And it's giving me just the very basics in this information. You don't see any of the pertinent soils information at this point, and that's because I didn't attach it from that tabular data yet, which we'll do in another class. But at least I can see the symbols here. The order in the table of contents is very important because it's the order at which you see things. If I pull my soil map units down below the base map, they disappeared. And that is because the order it's drawing is the opaque base map is being drawn on top of those soil map unit polygons. I can move those back up and see those again. A lot of lines here. So if I go to my streets layer, properties, I can add the labels to the streets in the same way. The street name, make it very large, bold, apply those. I can go to my symbology, and since I can see the streets on the base map, I don't need anything as far as lines. I can simply go to no color, OK, apply. Now I should be able to see the street labels at some point. Labels, the label engine really bogs down my ArcGIS frequently. Sometimes I have to turn those labels off while we're doing a lot of work because they don't, it takes a lot to generate those. Okay, so we've got a map, we've got a lot of things shown here. I can turn a few things off. There they are. There's I-70 and State Route 40. Everything's finally popped up. Let's add one more data set in. This time I'm going to add a DEM grid. A DEM is a digital elevation model. When you hear people mention LiDAR, this is what we're talking about. LiDAR is how the DEM was created by OSIP for the state of Ohio. I downloaded this from the website, which is a link on that handout, and DEM will look like the gray shaded tile that you see here. Each of the different colors represents an elevation, as you can see in the symbology, from an elevation of 1014.97 to 1014 or 1061.95. Doesn't help me a lot because I can't see what's going on behind it. Again, if I go to properties to the DEM, one thing I can do is make this layer slightly transparent. Now I can see through it, and I can see what's going on behind the layer. This makes working with multiple layers a little bit easier. I can also change the color ramp. So it's established a color to the different ranges of elevation. Black and white is one option. There's all kinds of different options to go through the different spectrum. Let's do a red to blue color scheme. Now this is showing the high areas in blue, flowing to the low areas in red. I can see through the DEM, and I can do a lot of reconnaissance work just at this level without having done anything to the data. And that's what you'll be doing mostly in this window. The map display is a lot of your just visual assessments and defining the layers at this point, symbolizing them, putting them in the proper order so that you can see what you want to see. And if we need to express this to someone and print this out, well, then what do we do? Okay, there are two views. If I look at my view tab here, a data view, which is what I'm in, and a layout view. If I click over to layout view, this gets me to a more of a paper map representation, or will allow me to construct a printable map of my map display there. So I have a data frame here, and I can, in the same way I did in the data view, I can zoom into a particular area if I need to. Pan and do all the same. I can also set this to a specific scale. I have now an option here as map scale. 1 to 5,777 isn't going to do me a whole lot of good, but I'm pretty close to 1 to 4,800, which is a more workable scale. And I can go ahead and resize that data frame as needed, move it around. I want to print this out. I can go ahead and go to the insert and add a couple of neat features, including some very important ones such as a scale bar. I've got a lot of different options for type of scales. We'll go with the one it defaults to. And I've added a scale bar. And one thing that you'll see, it doesn't necessarily default to anything that's going to be very usable to me. I can go ahead and stretch that out as easy as quickest way I like to do it, and put that so that those scale segments are now to a standard value, and I can actually take my scale or ruler and measure off 500 feet. I can go ahead and insert text at any place. So I've entered text here. Okay, I've entered text. Very hard to see there. I'll drag it down. So I've added text. Certainly would be good to add a north arrow. A number of different options to do that. We'll put in the standard one. Can move that along. And now I've got a map that I have made for a purpose. I can go ahead and very easily go to the File tab and print, obviously. I can also go to Export. File, Export Map. Click on the export. And I can save that map as a PDF or a JPEG, TIFF, or any other image file if I needed to insert this in something like an AutoCAD drawing, or just save it as a PDF to email to someone. Go ahead and cancel that. And that's the basics of developing a printable map.
Hey, Justin.
Yes.
I want to interrupt you again.
Yes.
And can you give me mouse control, please?
Yes. Send another request over.
Okay. The thing that, shoot, how do I do that? The thing I'd like to touch on is scales. We have a map that Justin has very intelligently put to a 1 to 4,800 scale. And the reason why that is fantastic is because 4,800 is divisible by 12. To make this map most compatible with our engineer scale, I'm going to double click down here on the scale bar, and I want to reformat it so that my 1 inch segment is actually 400 feet, because 4,800 divided by 12 is 400. So if I use my engineer scale, and I'm sorry to subject you all to this, but that way, when I look at the map, I can use my 1 to 4 scale perfectly, because 1 inch will be 400 feet on our map. So how do I do that? That's a good question. I probably should have practiced this. I'm going to adjust width, and then instead of it being 500, I'm going to make it 400. Now this right here is 1 inch, and it'll work perfectly with my engineer scale because my map's at 4,800, my scale bar is at 400 feet to an inch. Life is good again. All right, Justin, I'm done. Did that make sense? Send me chats if that was confusing, and I'll try to explain it or make Justin do it.
Thank you for adding that. Those scale bars, I don't know why they always pop up defaulted to some very obscure dimension, and you almost always have to do those little adjustments to get it to something much more usable. Lastly, what I'll do is, since we have a little bit of time, is add in a legend. Now you'll have options based on the data in your map of what you want to put in. I'll go ahead and pull out some of these items here. Let's just leave streets in there, and a lot of different options on how you want it to look. I'll just click through all those and leave them defaulted for the sake of time. Finish, and it created a legend for me, and you'll see that it shows me the streets are the lines that don't show up, and that's because I changed the streets to a no color. So if I go ahead back to my table of contents and rechange that color, now I picked another one that won't show up very well, yellow on white, but you can see that it coordinates the symbology in the map to the legend. So I can have a very nice legend setup that will help people understand what all the different layers are. As you can see, when I start getting 4, 5, 6 layers, especially if I add the land use and the map unit symbols and all of these other items, it'll be very difficult to tell what's what without a legend. Okay, so we're leaving a little bit of time here for questions. Kind of tried to cover a lot of the very basics to get everybody started. We'll expand upon some of these concepts and get into manipulating, it's probably not the best word, right? Creating and editing actual data in our next webinar. Any questions on any of the things I showed today? Any better suggestions? Like I said, there's, for some reason, good reason, there's always multiple ways of doing things, some better than others. Comment about scaling will be only correct if the map is printed to actual size, not scaled up or down. So that is true. Make sure that you print this to the actual size and don't zoom in or out, because you do have the option to go from 8.5 by 11 sheets all the way to poster size maps. So if you're doing something big, make sure that you print it to the same scale, otherwise that scale will be invalid. Thanks, chat, for that comment. I did see one, Megan, about clicking on the symbols in your table of contents legend, which I just showed there, and to very quickly change the symbology. I don't know if I mentioned too, and I did this though, but you click on these and to check with the check marks, turn them on or turn them off as you display them. So a lot of different ways to manipulate how you view the data once you have it in your map document. Okay, Justin McBride, you have a question? Are you online? Can I unmute you? I'm not able to unmute you for some reason, so if you can type that in if you have it. Okay, Tyler, question on panning when you're in paper mode. How do you do that? One thing that I struggle with is Arc will keep whatever tool you have open, and so when I start panning and then I want to go to click on something, I end up moving again, so I have to always default back to the arrow, which is kind of your basic selection tool. But if I have my hand, my white glove, I should be able to pan anywhere inside my data frame and move that around, so I can recenter my project site up as needed. If I go to the arrow, click on that, and now I click on it, I've highlighted my data frame, and you can see the little blue boxes. Now I can go ahead and do that, resize that if I want to make that a little bit bigger and fill up the whole sheet of paper. If I hold over the center of that, you see I've got the little 4 arrow direction things, and now I can actually move the whole data frame. So if you're using the magnifying or panning tools, it's going to move your view within the data frame. If you use the select elements, it will allow you to change the size or position of the actual data frame. Lat and longitude. Let me go back and look at the question here. Is how can I find and have it readily available? Well, a couple of things you'll see. Let's go back to the data view. And I should have mentioned this before, but if you look at the lower right part of your screen, you'll see, I don't know if I can highlight this, it's at the very bottom right, you'll see the bunch of numbers that are changing that are indicating the position of my cursor. So once I've got that map set up with a projected coordinate system, it is going to then give me, as I move that cursor along, what those coordinates are, again, in state plane. If I go to, yes?
Another good way, I like to use the identify tool as well to help me identify lat and long. So if I use the identify tool and
Okay.
click,
Let's click
midway down that window, there's the location, and right now it's offering it in feet. Justin, we don't actually have to pick a layer. We can go, do you see location in the gray box midway down your screen?
Oh, yes, okay.
Hit that drop down that's hiding over on the far right, and let's change it to degrees. You can either do decimal or degree minute second. I don't have a preference, but there's another way. Actually, I like degree minute second more because that's what SWIMS requires I do on pollution complaints. So that's, I don't know for any of you flat long into SWIMS, that's usually how I get it using that there.
Now this will be wherever, whatever pixel I clicked on. So depending on how accurate you need to be, we may need to zoom in a little bit further and specifically locate an item like that culvert, or just click in the general vicinity and get a number here that you can use. But that's a good tip. Thank you. I didn't think about that. GIS, CAD, all of these seem to be, I think we can all learn from each other. That's why we started these webinars and share some of the knowledge and some of these tips. Okay, any other questions? Comments? Complaints? Where do you get the culvert layer from? The layer I used was obtained from, let me see, either ODOT or the county engineer. I believe I obtained this from ODOT, which is the link in the handout that I gave you. There's a link to their GIS data site. They have a number of things on there, mostly pertaining to, obviously, highway transportation. I may have also gotten it from Madison County. They have a number of county layers.
So ODOT's layer, the one you have there, I believe, it gives all culverts on U.S. routes and state routes. If you're looking at a county road or a township road, then you have to go to your county engineer's office or your GIS coordinator, whoever you have, to obtain something for local roads culverts. Some counties do have that data digitized, others don't, so it really depends on your county.
Okay. And there will probably be a wide discrepancy of localized data sources based on your county offices and who and how much is done and made available. Some of it may be Madison County has theirs right on the website. Some others do too. If I Google county data, GIS data, Ohio, I could scroll through numerous websites there, various Ohio counties that had things available. Some others you may need to contact directly and obtain. Oh, okay. One comment came up. Thank you. I knew we wouldn't get out of here without a good question from my good friend Justin McBride. He's a beginning user, so he's got a lot of questions. He talked about adding data and connecting to a folder. I overlooked that. So when I went to add data, I opened straight up to a number of folders here that I use or have data stored in under folder connections. When you first start out, you won't have that, and you're going to have to navigate or connect to a folder. You can do that by adding, you go to the add or plus sign here, and it will ask you to connect directly to a folder. You could send this to one master folder where you keep all your different files and subfolders. You could send it straight to a very specific project folder to save you time. But you're going to have to then navigate where you keep that file at, connect to it to get to the subfolders to actually go ahead and add data. You will only see GIS eligible data. So if I click on a file here that has some other folders in it, you won't see anything in it because there's no GIS shape files or GeoDatabases in this particular folder. Okay, that was a good point. Any other questions as we wrap up here? It's almost 9:30. Okay, well, I appreciate everybody's time and attention. Hopefully you learned something. We'll expand upon this. Like I mentioned on I believe it's the 18th, we'll talk about the next level of basic GIS work and then build that into the hydrology tools on December 1st. And if there's other specific topics beyond that on GIS, please let me know that via email afterwards sometime later today, and we can look at where we go after that next year to put some webinars together if need be. Any feedback or comments would also be greatly appreciated so that we can learn how to improve this delivery system that we're exploring. Okay, well, enjoy your Friday, everyone. Appreciate your attendance, and with that, we'll go ahead and conclude the webinar.